When we first start to solve problems that have imaginary or complex solutions, at first glance nothing really seems out of the ordinary. It looks like an ordinary problem that we can solve with square roots. It's not till we get to the end that we realize we need a new kind of number, those complex or imaginary numbers. So for example, let's take a look at this first equation. 2x squared plus 11 equals negative 37. We'll start out like we would normally start out solving a problem by using square roots, by getting that square root isolated. So I'll subtract 11 from both sides. And then I'll go ahead and divide both sides by 2, just like I normally do, and I get down to the point where I now get x squared equals negative 24. And this is the point where we should recognize that we are going to be dealing with imaginary numbers, because once I go to take the square root of both sides, I'm taking the square root of a negative number. And those don't exist with the real numbers that we know. We can't multiply two of the same number to get a negative answer. So that's why we invented imaginary numbers. So when I do this, a lot of the same rules still apply. I still get two solutions. I have plus or minus. What I'm going to do though is take that negative sign that's inside the square root and pull that out. And I'm going to pull that negative sign out as an I, indicating that I have an imaginary answer. And then what's left inside the square root is just a positive 24. But that I is there to tell me that I do have an imaginary solution. And then, like we would always do, I still want to break this square root down and simplify it if possible. So doing the factor tree thing, I can break this into 8 times 3. And then keep factoring down to primes, so I get this factor tree. Finding my pairs, I see I have a pair of 2's, so that's going to come out front with the I, so I'm going to have plus or minus 2i out front. And then what's left over, same as always, is that 2 and that 3. They stay back underneath the square root and multiply back together. So my solution to this, my two solutions are positive 2i square root of 6 and negative 2i square root of 6. Now would be a great time to pause the video and try that second problem on your own. Work it out on your own, then check your answers against mine. Or if you want to, just let the video play through and my work will pop up and show you how I did this problem. And there you go. My answer was x equals plus or minus I square root of 6. I had an imaginary solution because I had a negative number that I was taking a square root of. I couldn't do anything with the square root of 6. There's no way to simplify that, so I left it the way it was.